Okay, so we're going to spend a little more time on this vector addition stuff. I'm going to give you one that's a little harder because it involves one of the two that you're going to add together having an angle that's not north, south, east, or west directly. Okay, it's at some angle in between two compass measurements. So what we're going to do is we're going to look at how do we add these two together when it wasn't as easy as before. All right. So remember, the key word for these are components. Okay, the key term is components. All right. You can only add components that are in the same compass direction together. Okay. For example, you can only add east and west together. You can only add north and south together. You can never add an east and a north together. It doesn't work that way. So the answer to this one isn't 30 meters at 30 degrees north of east-south. Okay, you can't just stick them together because they don't oppose each other directly. You can only add things that are in the same direction or in opposite, direct opposite directions of one another. All right. Now we're going to approach this the same way as before. First thing is you should draw a picture. Okay. So here's my origin. So for A, think of these as directions that you're giving somebody to get somewhere. You're going to start somewhere, and you're going to go 20 meters at 30 degrees north of east. Okay, that way. That's north of east. Okay, and I know that this angle is 30 degrees and not this one because I'm north of the east line. Okay, this is east of north, this is north of east. All right. After I did this one, I'm going to add on to it by going 10 meters south. Right? So I'm going to draw that in a different color. Now if you notice, my two arrows are different lengths because these are different lengths. This is roughly half of this one. If I were to ask you to draw one that was perfect to scale, you would use a protractor and have a scale factor like 1 meter equals 2 inches, something like that. All right? So if we're trying to add them together, we're trying to see how do I get from the very beginning to the very end in one move. How could I replace these two with one? All right? So really what I'm asking to do is I'm asking you to find C, which is somewhere in that direction. All right? So this is really what we're looking for. All right, it's always important when you're doing vectors that you draw a picture first because it helps you check and make sure that you're doing things correctly. So I'm going to do it exactly the same way I did it before. I'm going to make a chart where I'm going to add A and B together to get C. Okay? And just like before, I can only add my X part of A and my X part of B, or my components of each in the X direction together. And now I can only add my Y components together. All right? So I have to identify how much of A goes east and how much of it goes north. All right? So I'm going to draw it separately just on its own, like this. So I got 20 meters, and I got a 30-degree angle right here. All right? How much of my first A is in the X, how much of it is in the Y. Really what you're doing is you're making right triangles for yourself to work with. All right? So this is where trig comes in. If you remember from geometry, you learn about SOHCAHTOA. Okay? Now a good thing to remember is you see this, the magnitude of a vector when it's written like this, that is the hypotenuse. Okay, hypotenuse. All right. So really, you have the hypotenuse, and you're looking for the adjacent and the opposite sides. That involves some trig. Okay. So if I'm looking for AX, AX is really the adjacent side. Okay. So I'm going to use cosine. So the cosine of the angle equals adjacent over the hypotenuse. So you end up with 20 cosine of 30. Okay. Hold on a second, let me get my calculator. So we're looking at 20. Now the cosine of 30, I have it memorized in my head, is 0.866. Okay, so that's going to be it's going to be 0.866 times 20. That's going to be 17.32. Okay. Now for AY, I'm going to do something very similar, but I have to use the sine for that one because I'm looking at the opposite side to that angle. So the sine of 30 now equals AY over 20. All right, which I end up getting 20 sine 30, which is 10. Okay, so I now have how far did I have to go in the x and the y in order to end up between here and here. Okay, and I'm only looking at the blue arrow because I'm only focusing on the A vector right now. So really, if I, instead of going 20 meters north of 30 degrees north of east, I could have walked to just do the blue one, 17.32 meters this way and 10 meters this way and gotten to the same place. Okay, I'm breaking it down into the two directions, east and north. All right, so now I have my two parts. I have 17.32 and I have 10. And they're both positive because I'm saying east and north are positive. All right. Now, if you look at the B1, B1's actually a little easy because it's a straight shot down. There's only south to it, which means all of this is south. So I have no x to my B vector, but because it's south, I have to show this. Okay, I have to show that it's negative, okay, in order to add them together because I can't put south in my calculator. So now that I have that, I can just add the columns because I'm just adding the components. So I end up with 17.32 and 0. So I just found the east-west amount for C and the north-south amount for C. So what did I end up with? Instead of going 20 meters at 30 degrees north of east and then turning and going 10 meters south, I could walk 17.32 meters east and 0 meters north or south and get in the same place, end up with the same result. All right? So my answer for C ended up being a nice, easy answer because there's not two directions, so I end up with 17.32 meters east. Okay, I have my magnitude and I have my direction. Now, if you want to be clear about this, I only have one sig fig in both of my magnitudes, so I have to keep this at one sig fig. So really, this should be 20 meters east. Okay? So go through this, and if I made this also at an angle, you would still do the same thing. You would do just what you did with A, do the same thing with B to get your values for your table. Okay? You can use this method with distances, with forces, you can use it with momentums, okay, any vector, okay, you can do this table method with. All right, so look through this, write down your notes. If you have questions, make notes of to yourself or in the margins around your notes and ask me in class, email me about it. All right, and we'll get you all squared away because this is a very important thing you have to be able to do in order to keep moving on through physics because so many things are vector quantities. Okay?